Hi and welcome. New episode of the Maritime Innovation Update. My name is Jonathan Weisheit. I'm a research associate here at Fraunhofer CML. And today I will be talking about the AutoFlex project. I see still people are coming in and joining. So before we start with the content, we'll wait another minute. But nonetheless, I have some other important things I would like to say here. This session is being recorded. So if you want to stay private, stay muted, keep your camera turned off. If you would like to engage later on in the process, you can do so. You can send a message in the chat, or maybe if you have a very urgent question, you may also turn on your camera, turn on your microphone, and involve in the ongoing presentation. I need to fix my screen, so there are my slides. I'm not alone here today. We have a guest on the MIU. It's the project coordinator of the AutoFlex project, Odd-Erik Möchrit. Welcome.
Thank you, Jonathan. It's a pleasure to be here.
Yeah, thanks for being here. Totally welcome. Odd-Erik, for the people who don't know who you are, who or what SynTeF Ocean is, maybe a few words about yourself and what you're doing.
Yes, I'm a research manager in a group called Maritime ICT and Cybernetics in SynTeF Ocean, who is part of the bigger SynTeF. I guess most of you have heard about SynTeF. It's quite similar to Fraunhofer in many ways. We have 2,000 employees and we have different institutes doing different kind of research, but I'm then representing the ocean part, as you said.
Great, thank you. I heard the formulation before. So SynTeF Ocean would be the Norwegian Fraunhofer, maybe you can say so, or the other way around. Maybe SynTeF is the German what? No, SynTeF Fraunhofer is. Oh no, I'm confused. I got lost. But you know what I mean. We're here to talk about the AutoFlex project anyway. So I announced the recap of the first half of the project. Can you believe that we're always halfway through? I mean, we've been doing so much, but taking a look at the agenda, there's so much more to come. For the people who don't know what AutoFlex is, we've got this graphic puts the whole concept in a nutshell. So, of course, in the center of the project, there is the autonomous vessel. Small, flexible vessels navigating through canals, waterways. And the goal is to have cargo transport distributed off the road onto a vessel and using small electrified autonomous vessels to transport cargo. We have this idea that we use these vessels, and of course, the cargo needs to go onto the vessel. How could this be done? We have some ideas. We have some building blocks. We call one of them stow and charge. So this is where the vessel that is being electrically driven or propelled, we use some energy there and should be charged up. You can, of course, load containers from the truck on the vessel and back. We have temporary port terminals, so we would like to exploit infrastructure that is there but not being used, and mobile distribution centers for city injection. So in a nutshell, this is the AutoFlex project. And let's now take a look what the key contributions of AutoFlex will be. I mentioned inland autonomous navigation. So this will be demonstrated in full scale. Work package 6 has been kicked off this week. We will talk about that in a minute, more in detail. Then, Odd-Erik, what do people need to know about the uncrewed zero-emission vessel? We have a little picture here of what we think it could look like afterwards. Will this be built within the AutoFlex project?
I will not build the ship itself because the budget is limited, but we will make a scale model, so which will be tested at the DST facilities in Duisburg.
Exactly. This is coming up later this year. There is a deliverable online on our homepage, how this whole vessel was being designed, how autonomy affects the design of the vessel. There has a lot of work been going on that. And of course, we don't want to have this vessel staying on its own. There will be a zero emission transport transportation network. Odd Eric, what is the idea behind that? So usually we call them two use cases. Maybe a few words from your side about the use cases.
Yeah, the main use case, so to speak, is the one in the western coast of the Netherlands, where we are planning to show that we can actually exploit what we call underutilized network of small canals. Today, there's mostly leisure crafts that go in these canals along the coast between Den Haag and Leiden and Haarlem and all these bigger cities there. We want to show that these vessels, special made for SAM2, can transport cargo close to the end customers in the cities and outside of the cities, just as efficient and cost efficient as trucks.
Exactly. This is our big competitor, right? Trucks, they're everywhere. And I guess the idea of Autoflex is to change that.
It's a competitor and a collaborator, I would say. We're also trying to show that we can utilize the smaller electric trucks and e-vans and these kinds of things to do the last mile. So I think it makes sense that the electric trucks don't have to do the long haul, but they can rather stay in the last mile part in both ends of the network.
Great. Let's take a closer look at work package 6. It was started this Wednesday. It's one of the, I don't know, would you agree it's one of the most important work packages? And the fun part is within that one. So till now, there was a lot of groundwork that needs to be done, building the basics, a lot of research on the desk. And this one will be where we have some more hands-on experience. So I put a map here. Terneuzen Lock, city of Ghent, and city of Antwerp, so everybody knows what we're talking about and where to look at. Odd Eric, what is the plan for the Terneuzen Lock in connection to Autoflex?
Oh, we have some really exciting plans here, Jonathan.
So exciting.
So what we are going to do is to take an existing barge that is commercially operating today, put some equipment on it from our partner Maritime Robotics, who works on the autonomous navigation system. And then from a remote operation center, I don't know if we should spend time on explaining what that is, but it's basically a location onshore where you can control the vessel from. And then from the terminal of the FTS in Ghent, we will show that we can, from the remote operation center, download what we call a mission to this barge, and the barge starts sailing by itself up to the Terneuzen Lock, also then crossing the border between Belgium and Netherlands, and head into the lock, and that marks the end of the demonstration. But it's quite ambitious one and something we really look forward to.
Definitely,
As
yeah.
you said, great fun.
Great fun, yeah. It will be, I think, the highlight at the end of the
Challenging
project.
also, but fun.
Very challenging. I guess what most people are not aware of, that we actually started the whole process. So my colleague Mert, he's working with data that has been collected by our full-scale model. So we're already collecting data and trying to evaluate, okay, how does maybe an encounter with another vessel affect the autonomy and the steering of the vessel, and what can be done from this remote center that you have been mentioning. There is so much to prepare because everything is new. Yeah, and then in the end, hopefully everything works out, but there is yeah, still some time to do this. DST, you mentioned them. They will be having not only this scale model that will be tested in a towing tank, but we will also yeah, use this Veli lab that they have for validation purposes. Maybe just a few sentences about what can we expect from having a validation in a simulator.
First of all, we will do what we call a hardware in the loop testing with the simulator. that's basically including the autonomous navigation system controllers from maritime robotics, the physical controllers into a simulation setup. So we simulate the actual vessel, and we have the control system in there, so we can do a test, a virtual test, and that would be like a copy of the actual demonstration that we do. And the nice part with the VLab is that this is state-of-the-art remote operations center autonomy kind of setup, so we can it would be like being on an actual barge and doing the simulations. So and doing this kind of testing up front would make the we can sort out the different kind of failures and non-functional things in the simulation setup rather than doing that on the actual demo day in the canal.
Yeah, thanks for pointing that out. Let's take a closer look at the vessel. So you were mentioning we want to test hardware in the loop in a simulation because, as you already said, we will not build a new vessel, but we will provide a very detailed design. Let's take a look at the highlights, or maybe what distinguishes the new AutoFlex vessel design from a design of commercially available inland vessels. As you can see them now going on. We will be having a new hull design. You can read about it in the deliverable 4.1. It has been published, I think, at end of April, so you can download it from the AutoFlex homepage.
4.2 actually, but yeah.
Thanks for clarifying.
Both of them relevant.
Definitely, you can, if you're diving really deep into it, you can just read both of them. Okay, so let's get back to the vessel. We see communication navigation center. So there is antenna in the bow. It will be used for the remote operations and the autonomy part. We have a bow thruster that is working hand in hand with the azimuth thrusters and electric propulsion. So this is part of the zero emission idea of this vessel. These should be for improved navigation, improved steering on especially narrow canals. As we've been mentioning, we want to conquer smaller canals, smaller rivers. And then I see a containerized battery flying in. What is the connection to battery? And is it really the size of the container, Odd Eric?
It is indeed. It's a very interesting concept that our partner from the Netherlands, Zero Emission Services, are. There's actually a product already. That the principle is that you have within a standard 20-foot container, you have a battery package of like 2.7 megawatt hours, and this you can, instead of charging in a traditional way, you can then just swap the container batteries, and so they are just connected with a standard plug on board the vessel, and then you can easily just swap them when you're at the stow and charge, for example. So while doing cargo operations anyways, you can also swap the energy containers and you're good to go.
Yeah, that is the idea behind the containerized batteries and the stow and charge concept. We've been talking about water waste, underutilized waterways. We tried to show and explain what that is with this map. So as you can see, this is our use case area, the Netherlands. We have hundreds of maps. I think DST did a very great job in getting information on where these waterways are and what size they are, what infrastructure is there. So maybe, Odd Eric, from this example, how can we imagine will there a benefit of using this underutilized waterways?
There's a lot of benefits. As you can see, there are the dark blue ones, I believe, are the smaller waterways. So there's a lot of them. In the same areas I mentioned on the west coast, today is one of the most congested or traffic roads in Europe. And when we look into the data, we see that a substantial amount of that traffic is trucks, basically. So we believe that if we then move that to these AutoFlex vessels and we utilize the waterways instead, we can reduce that traffic quite a lot, which would have a lot of benefits, not only from an emission perspective, but also from noise and from accidents and all this, what we call external costs for the society.
That's true.
And hopefully we can also, by the small waterways, get quite far into the city centers, so we can more or less do most of the last mile as well.
Exactly. And this is something that CML has also been very active in, laying the groundwork here. Looking at the cargo flows, what cargo is being transported, putting a highlight on what is maybe most efficient to be transported with a vessel, or putting it on an inland vessel. Because as you said, most of the cargo needs to be delivered into urban areas, and people are trying to get this, and not everybody has a river flowing in front of the house, or their store, or whatever they need these cargo being transported to. So part of the whole transport system is not only the vessel, but as been mentioned, the stow and charge. And then maybe taking a look at the time, we're already pretty far ahead. There is so much more to talk about, but maybe we can make it quick and release people to their well-deserved lunch break. So just a few words, maybe what can we imagine is a temporary port terminal, and how does a mobile distribution center work?
Yeah, so just quickly about temporary port terminals is that what we want to achieve in the project is to utilize existing infrastructure, so we don't have to invest and take more of the land areas, which is very valuable from before. So if we can use the existing infrastructure, like old quays that is no longer used or is just partly used, we look into how we can easily use that efficiently and as a temporary solution based on a need in that area. And in the same context, we also look into what we call mobile distribution centers, which could most probably will be a container, self-contained container with it's self-contained in terms of power and solutions, so that it can be used for retailers or for end customers to come there, pick up pallet or some kind of package that is a lot of these things inside a container, so you can do the distribution from there with small events or electric bikes or whatever.
Exactly.
Quickly.
Yeah, during the preparation for this meeting, we already agreed that for each slide we could have MIU on its own and maybe give a presentation. So it's really hard to sum it all up. I hope everybody in the audience at least got a rough idea of what is going on and what the ambitions of AutoFlex are. Because yeah, what's next for AutoFlex? Taking a look here. This one actually happened already this week. So our colleagues from NTUA, Konstantinos and Marios, they have the latest publication on the SIGA 2, which is also being developed in cooperation with CML. If you want to know about it, there is a link, there is a post on LinkedIn. You can find a link to the publication. Maybe take a look there. Then later this year, AutoFlex will be at the IMAM, so the International Congress of the International Maritime Association. This will be focusing on the validation part, so CFD methodology for propulsion performance and for CFD tools for the design of marine propulsion systems. Your colleague Vladimir Oderic, he's the main author of the head author of it, and of course, as usual, these scientific publications are a team effort. There are other people involved too. And then I think very important, and I cannot leave anybody without saying that, yeah, AutoFlex will be at the ICMAS conference. So in Hamburg in October, Fraunhofer CML is hosting this event. We're co-organizing together with Digon. Oderic, should we already tell what we have planned for AutoFlex at the ICMAS, aside from 3 publications, or should we keep maybe secret and surprise people?
We keep it as a surprise for now, I think, so we can make sure that we have everything settled. But there's gonna be some exciting stuff.
There's gonna be some very exciting stuff. So I think we can mention that AutoFlex will be a sponsor of the ICMAS. So there will be something going on. AutoFlex will be present and visual. Yeah, if you're interested in joining the ICMAS, the registration is open. Go to the homepage, degon-icmas.org, or scan the QR code. We'll be very happy to see you there. We're running out of time. There is so much more to say. There is so much more going on. If you have the need for more information, go to autoflex-vessels.eu or scan the QR code. There is so much more information. Of course, you can reach out. Or Eric, we can find you on LinkedIn, right?
Yes, you can.
Okay, and also you can always send an email. You can send an email to me. I'm also on LinkedIn. Feel free to contact me or Eric with whatever any questions you might have. Thank you so much, Eric. It was a pleasure having you here. Thank you for contributing and telling people a bit about the AutoFlex project.
Thank you for having me. It's a pleasure.
So this was it for this week. Next week, there will be Adrian Freiter. I have to admit, I was a little confused. I thought I lost it all, but he's not actually from CML, but he's involved in the DivMata project, and he will be presenting latest results of how to digitalize emission regulation compliance. He will be doing that together with my colleague Hannah, and she's from CML. I know about that. Don't forget to register. Is on Friday next at 12 o'clock. There is a link in the chat. I think you know how it goes. You managed to come here today, so don't miss to join in next week again. And thank you everybody in the audience. Have a nice weekend.